Hello all, welcome to Data with Abhi. So today we are going to see PySpark SQL normal functions. So we'll just see it step by step reference with examples and visualizations. So let's start with this PySpark SQL normal functions. Okay, so in the PySpark SQL normal functions, so what are the different kind of functions we have? So normal functions are the kind of a fundamental building block of every Spark pipeline we build. Unlike aggregate or window functions, normal functions operate row by row, transforming, referencing, or evaluating a value for each record independently. So they cover column referencing, literal injections, conditional logic, null handling, typecasting, collection creation, hashing, and more. So we'll see it step by step when we go forward. So don't get confused here. So a standard import of the these normal functions. So we can use top level imports from PySpark package, which is from PySpark.sql.functions import. If you mention a star, each and every function will get imported. Okay. So but we'll import it as a functions. We'll import it as a F. So we can utilize only needed functions in the downstreams. Okay. So I have categorized those functions into different categories like column reference literal values. Let me show you here. So I have categorized it to different. There is a column reference. In the column reference, we will see the column and expression as a key functions. So primary use case for this is to reference or compute the column. Okay, so unlike to cast the column, we have to reference this. So in the literal value, we'll see literal type literals. In the conditional logic, we'll see when otherwise collects nan values. And in null and nan checks, we'll see is null, is nan. In typecasting, we'll see the cast via column use as this one. In collections, we see array struct, create map from arrays. In the row ID and partition strategies, we see monotonically increasing ID or a Spark partition ID. Okay, so in the random values, we see rand and randian. In hashing, we'll see different type of hashing, including hash XX hash 64 CRC32 MD5. There are many more, so we'll see the detail when we go forward. Again, there are multi-column comparison, greatest or least, broadcast hints or shuffle hash join. Okay, so we'll see that too. In the source metadata, we'll see the input file name when we work with the Databricks. Okay, so from which we'll start with the column reference functions. Okay, so the column reference. Let me create a into. So we'll see the column reference functions. Inside the column reference function, we'll see column. Okay, I'll create this as a one. First in column reference, we'll create it as a two. This we'll create it as a three. Okay, this is column and column reference. So column name returns a column object from a given column name, and column is an alias for the column. They are primarily way to refer to data frame column inside the transformation expressions. So the syntax to utilize this, before the syntax, we'll see how it works in visualizations. Okay, so let me show you that. Let's say this one. So if we imported the function like column, and in bracket we provide the column name. So in this case, column name is any of the data frame. It returns the column object. There are a Pythonic way to extract the name, which is if you have defined the data frame, then we can provide the in square bracket as a column name, and it will return again a column object, but it is bounded to the specific column, and it is not optimized as per the Spark application is. But this function column is optimized. If you want to add some literals into the column, then we can utilize these uh, functions to add literals. So it will return a new column expressions. Again, if you want to add conditions, you can add that too. If you have added a condition in this way, it will return the boolean value, which is a true or false. Okay, so let's see its implementation in real use cases. So let me show you. I have prepared one case for you. Okay, I have created the data. Let's see the data how it looks like. Okay, so in the data we do have the ID, name, and score. In ID, name, and score, we do have the three entries here. First one is for Alice, second one is for Bob, and third one is for Carol. So we'll utilize this data frame to see the use cases of this column and columns. So now this data frame is ready. Now we can see like what are the different method we can use. So first method we have seen methods one we have seen is using column in bracket column name. Okay, so I can I have to use this f since we have imported it as a it as a f. Then we have to import. Okay, import PySpark SQL function as f. Okay, so we have to utilize the f dot column. Okay, so let's see how it can be implemented. Let's see, we will select df dot select then bracket. Let's provide the column f dot column. It is providing address suggestions, but we'll type it manually because we have to we know about what are the things is going on, and we should have the hands on while we write because some of the companies has not implemented the AI thoroughly since it's a like a free version that I am using, so that's why it is enabled and it is showing me the suggestion for this. So let's see from this method what are we are getting. So with the select the name and the score, we have utilized this column functionality. So it is taking those rows. There are the different method that to select the column. We have the to method to using df, which is df column, and here we provide the column name, which is and actually it shows the identical agent. It shows identical results as above. Okay, so let's see select and bracket df, then we can provide the name here. Okay, and then what are the second df in square bracket there is a score, then complete the bracket, then type it as a show. Both would give the same result. So this is a second method to retrieve the column. Okay, and like we can use the columns for the expression that we have mentioned earlier, which is this one. So this will return the expression. So if there are the aggregation, we can add literals in to provide the aggregations. Okay, here we'll yeah, do the simple cases like column inside set expressions. So let's see. Let me select those column. In the select, we can utilize f dot column side name comma f dot column inside we'll add a score and we'll multiply the score by 10% increase. So to increase the 10%, we have to multiply by the 1.1. Let's see how it shows multiply score. Okay, so you can see like we received this 105 instead of 95.5 for the Alice, and for the Bob it is 90.2 instead of 82.0. Okay, so since here we see the expression itself, so we can alias it to the different name. Okay, so we'll see that alias in down the line. So meanwhile we'll keep it as it is. Okay, so let's say now we have written uh, did the some aggregations, which is multiplication here. So let's see another thing here, which is a conditional, like which returns the boolean value into the column. Okay, so let's copy the same thing, and in the score itself, instead of multiplication, we can add a comparison operator. If the score is greater than 90, then it should show. Okay, now here you go. We get the boolean value true, false, true, false. Okay, so let's see the score as well here. So you get to see the score as well, so it will be better to understand. Now there you go. 95 and 5 is greater than 90, and that's why it return the true. 82 is less than 90, that's why it return false. Likewise, we can get the Boolean expression in the derived column. Okay. So this is all about the column. So prefer tip here to use a f dot column over this second method. Use the method one, which is very much optimized and reusable functions. Okay. So avoid using this second method, which is df dot name. It is a kind of a pandas verified assessing method. Like in pandas, we have to assess it this way. There are another ways to assess the column, which can be like we can assess it df dot name. This way also we can see the return this name. Okay. Okay. Sorry, we can add it as a show. Maybe this is not accepted here. Let me see. We have to. Okay, we can directly pass the name as in we pass it in a SQL instead of mentioning anything. We can pass it as like this. Okay. So this method can be utilized, but if you want to do aggregation, want to derive some expression, then we should use a column functions here. So it doesn't bind to a specific data frame. So making the code easier to compose for the JVM objects, which Spark utilizes. Okay. So this is all about the column referencing for the columns. So either we can use a call or column. So actually call is alias for the column. So both are the same. Okay. For more, you can see there is a API docs Databricks guide here for this function. You can come and see here. So if you click on this normal function column, it shows how we can are able to get those data using this function. So there is some like top level they have mentioned. So but I'm mentioning and telling you in a very detailed manner so you can easily understood this. And this is how it works in the production environment as well, actually in the development. So we can utilize the different method. There are the company standards and practices they built. So based on that, we can use our code and we can refactor our code according to their standard practices. Okay. So now we'll move to the next functions, which is a SQL expression as a column. Okay. So like we have seen previously, which is the expression as a column. Let me show you that in the column reference functions. We do have second one is a SQL expressions. So there are many more functions. It is not mentioned in this table, but we are gonna see those because those are also the important functions. Okay. So let me create the topic here, which is expressions. Sorry, this is supposed to be second point here, SQL expressions. So this expression parses a SQL string expression and returns the column. This lets you write a arbitrary SQL style logic inside a select or with column and filter, including case when functions call arithmetic and sub expressions without switching to the SQL context itself. So let's see how it works. Before that, let me show you one table where the different ways of implementation can be seen. Okay. So let's see here. Now here it goes. So inside a expression function, we can pass two different column addition. Okay. This is equivalent to column A plus column B. It returns a numeric column. Here we can pass the Boolean expressions, comparison operators here. So this is a conditional operation. In expression, if column A value is greater than 90, then it should return the Boolean value, which is true or false, which is equivalent to column A greater than 90 that we have seen earlier. In another way, if you want to do the conditional logic using a case when statement, like we used to do it in the SQL, here we can pass in expression case when a column A is greater than 0, column A value is greater than 0, then it should return 1, else it should return the 0. So it is similar in case of a PySpark Pythonic way. We can utilize this when column is A is greater than 1, 0, then it should return 1, otherwise it should return 0. So it returns the integer column because we have mentioned the 0 and 1 into the query. Okay, so there is another expression we can see here, expression upper name. So this is actually the SQL like query that we can return inside expression expr functions. Okay, so and it is similar equivalent Python or PySpark which f dot upper. Again, this is a SQL function that can be imported from PySpark SQL function libraries. And again, we can pass the column inside it. It would return the string value in the uppercase. Again, there is another which is a between function between and. So here it is asking like if a between 10 and 20, okay, then it should return the boolean value which is true or false. If a is between 10 and 20, it will return true. If it is not between 10 and 20, it will return the false. And the similar equivalent case can be implemented PySpark or Python logic, which is column A dot between 10 comma 20. So the equivalent PySpark it's look very similar or very simple for the implementation, and the possible possibly it is very much readable, and any programming background student can understand this logic. But in left side, it is just a similar kind of a SQL based logic we can implement inside AXPR functions. Okay, so the purpose of this function is only to implement the SQL style logic inside the functions. Okay, so let's see the implementation in the Databricks notebook. So here we utilize same data frame, or we can create another one. Okay, so I have modified some columns in it. Okay, let's see how it looks like using a df.show. So there you go. So name, math, and science. So there is a name of student and their subjects. Inside subject, we received their scores or their percentile they have received, or we can consider as the marks they have received in that specific subjects. Okay, so we'll implement the logic here. So what are the logic we can implement here? So let me try to select these columns using and add the expressions. Okay, so now we have selected this df dot select. As you know, df dot select is similar to select star from employee table. So this is a similar case. Inside select, okay. So we'll implement the select the columns using a f dot column inside that we'll pass the name. Okay, give the comma. Again, use the expression to add the math and science, both of the let's calculate the total, the total marks received by the each candidate or each student using the expr. Then I will use expr in bracket, and then we can pass that column. Okay, I will pass this math plus science. So now we have passed this as a expression. Then we have to add some name to it. Okay, so I will alias it. So this is alias. We see these aliases in depth. Basically, alias is to give the namings to the derived columns. Okay, so I will add it as a total. Okay, so another expression can be derived like we seen in the example table. So another example can be like expr in bracket. So we can implement the case when logic here. So let's see if the mark is greater than or equal to 19, then its rating should be there. If the when math marks is greater than or equal to 75, then its rating should be B, else it is C. Okay, so we'll implement this condition as a grade. Okay, so let's write it in SQL way. So we can write case. So I am formatting this in a good manner so you can understand it easily. If math is greater than equal to 90, then so now I'm using a multi-line string here. We can implement the multi-line. Okay, multi-line string here. Let me add the enter. Okay, then we should rate it as a give the grade as a A. Okay, then next condition will be like when math is greater than or equal to 75, then it should get a rating as a or grade as a B. Or else we provide the grade C. Okay, now we have provided this entire thing. After the case has been initiated, okay, we have to end this statement. Okay, so now we have ended this statement. Now we should give some aliases to it. I can give the alias as a grade here. Okay, so now grade has been decided. We have created that. Let's like give the weightage to the math and science, and then calculate the weighted values or weighted grades here. Okay, so let's again import this take this function dot axpr. Inside it we can calculate the weighted average, which can aggregation can be provided like 40% to math plus, and science would get 60%. It is so weighted average. Okay, then we'll see the data frame how it looks like. Okay, so now our code is ready, we can ready to execute this. There you go. So in the name, we can see Alice, their total marks in both subject math and science, and they are graded. So since the in the math, Alice got more than 90, then his grade becomes A. And the weighted average, which is calculated based on this formula, which is math goes at 40% and science goes for the 60%. It is calculated to 86.20. Okay. So you can see in the total, we are getting null values for Carol. So actually, if you see, Carol does not have the total value as a null. Okay, so since null cannot be sum, so that's why it returns the null. In aggregation, we should handle the null properly. So null handling we'll see in another lecture. But if you see, the null cannot be added, multiplied, aggregated with any other column. So if you deal with the null cell, then it will again return the null value. Okay, null is nothing. That's why it does not get considered in any of the operation. That's why Carl get total value as a null and weighted as well as it is as a null. Okay, so before this, we should have implemented some values here to handle the null, or we can implement some zero or average value inside the null. Okay, so this is all about the EXPR. So key concept here is EXPR is especially powerful for porting SQL queries into the PySpark without rewriting the every clauses. Let's say there are the migration work going on and we don't want to port the each and every query into the PySpark code. Then we can use the EXPR functionality to copy and paste the query into this. Okay, and you can use it to leverage SQL case when between in and function syntax directly into it. Okay, now we'll move to the next topic. So for normal functions, uh, specific to this column reference function, there is the column. Second function is a EXVR. Okay. Now we'll move to the literal value functions, which is lit and typelet. The literal value functions. What are the literal value functions? The first one is a like lit functions. Okay. Let me create it cell here. So lit it injects the constant value. Actually, it creates a column containing a single constant literal or a single constant value that is applied to every row. And type lit is does not same as lit, but it preserves the exact Scala or Java type that we have mentioned here in actual case. So essentially for the complex types like a list and maps. So let's see the literals. So it wraps any Python value like string, integer, float, boolean, null, or nan values into the column of that constant. So let's see the actual table which explain this literal. So there you go. Now we have the row, name, scores, and literal active, literal 24, literal true. So if you see in the row, name, and score, these are the present column. Now we have added a literal active. So each and every row gets a active to the corresponding row. And in similar case, if you add a integer 2024, it provides a constant value across all the row. Similarly, in case of Boolean value, it provides a constant value across all the row. Okay, let's see its implementation in the PySpark code. So syntax of this will be like so f dot lit. So this is a function, so that's why we have to provide. In column, you can provide any kind of things here. Okay, and it returns the column. Column is a literal value, not a column name. Okay. So let's see its implementation in actual case. So take the similar kind of a data and let's see how it looks like. Now we have again picked up the similar data, which is name and their scores. In the name, we do have Alice, Bob, Carol with respective score. Okay. So let's see how we can implement this later. Okay. Let's select these two columns. Okay. Let's say df dot select and bracket. We have to select this column. So how we can select this column? Either you can provide this kind of the structures. Okay. Now I have to implement the show here, else it will return the error or nothing. Okay. Now following column, it should be like in the inverted comma. So I made a mistake here. Okay, this is similar to SQL based query. We can pass here, but now we have to sorry. So we have to implement the literal as we have seen in the table. So first we will add the active column to the each row. Okay, let's add it. Then we can use f.lit and bracket. We can give active. There you go. Now we have added active column. So if you run this cell, I will get a active rows. Okay, but the name is active. So I will alias it to the status. Then it will show the status as active. Similarly, we can add a integer value, which is f.lit. In bracket, I can add a 2024, which we have discussed, and we alias it as a year. So it should show the year as well. Now each and every row gets the same value. Similarly, if you want to add any other which is a boolean that we have seen, like you can add it as a literal. In this, we can pass the true or false value. Let's type a true, which is Pythonic true. We can add it as a condition as a boolean. Sorry, boolean. Now we'll get the boolean value. If you add a false here, it will return false to each and every row. Okay. So let's say if you want to like add a null value. Okay. So we can directly add a null value using a none. Okay. So in bracket we can pass a none, and we will add a alias as a, so I will type it give the name as a null literal. Sorry, the comma is missing here, so that's why it's showing an error. Now there you go. You can see the null values to each and every record. Okay. So like this is how we can implement the literal. Okay. So important thing to note here is literal is required when combining column expression with a Python constant. Writing column score plus 10 works, but concatenate column name inc won't use a concat. Okay. So instead we have to use a literal. Okay. Let's see its implementation. What I'm trying to say. Let's take an example. So if I want to add the column, okay. So in this, now we do have the literal. Let me remove this. We'll see it here. So in this literal, let's say if I want to create a one more string, which is concatenations. Okay, let's say. So we'll see the concatenation later, but concatenation is to merge two column values together. Okay, let's say I do have this, yeah, and I am trying to concat this name with this literal. Okay, so now this should have worked. Now it is showing a red line. Let's see what happens. Concat is not defined. So the issue here is like we have to import the concatenations. Okay, so before that, we can avoid importing. We can directly use f.concat that can be get from the functions. Now there you go. These Alice and the 2024 get concatenated together. We can provide the space again here. We can provide this kind of a space. Okay. Now this should have concatenate, but what happens here is it is showing the cannot resolve error with did you mean of the any of the following. Like it is giving an error unresolved column with the suggestions. So how we can modify? So the thing I am mentioning here, so we cannot pass this space directly. Okay, since it is single space, we have to mention this into the literal. Okay, if I mention it here as a literal, okay, and passes a space into it, then it would work. But the empty space won't work there without a literal. There you okay. So that's why if you want to concat two names, we have to use this literal. Okay, we cannot directly concat without the literal. Okay, let's move to the next type, which is a type literal. So type literal is for the complex types. Okay, let's create the comment here. Okay. So it preserves exact scalar types or Python list. Like if it is an array, then it returns the array. If it is dictionary, it returns the map. So letting you the broadcast structure constant to every row. Okay, let me show you what I meant to say in the actual implementation. Let's create a data here and let's see how data looks like. Okay, in this case, we do have only two records, which is a name. Inside the name, we do have two records, Alice and Bob. Okay, let's select their name. Select the column. Okay, let's df dot select bracket. We provide pass the name. Okay, so let's see what I meant to say. So if I type f dot type let in bracket, if I provide the literals to this, let's say I will provide a list as a type letter. So I will provide 1, 2, and 3. Okay, and I will give it alias as a fixed array. Dot alias as a fixed array. So now it should return me this list in the proper way. Sorry. So it is showing an error. So there might be issue with this one. So 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 in typelet actually it is not available in the PySpark version. It can be utilized into the Spark or utilized into the Java or Scala programs. Okay. So here we instead of typelet we should implement the array, which is array for this one. Okay. Let's try to implement an array here. So to implement that using array, we should implement this way. F dot array in bracket literal or x into the list. Okay. Similar way, we can implement the map as well. So how to implement the map? We should use create map functions here. Okay. How can we utilize that map function? Let's see. F dot create map. So to utilize this create map function, similarly, we can as above we can mention those key value pairs here. Okay, so now for k, x and y, like k and value x and y, let's type it as a k key value. Okay, or key value we can type it as a key and value, like here we can type it as a key and value for a, for one for a, two for b, and we can iterate those items using a for loop using for x and kv. Okay, this is not a fixed map. This is not a fixed array. This is a mapping using the dictionary type of format. So you can see here. Now you are able to create the map and the array inside the data frame. Okay, so we'll move to the next functions. Which is conditional logic, when and otherwise. Okay, so in when and otherwise we can see the different conditions, like when. So to use a when in PySpark, it is equivalent to case when or if then else with the SQL. It evaluates a Boolean condition for each row and return the corresponding value. Multiple when calls and call can be chained for multi-branch logic and otherwise provide the default fallback, like the else condition in the SQL. So to implement this case and when, we'll see the different approaches. So first approach would be like single branching. Okay. So in the single branching, let's see how it can be implemented. So we'll see the step-by-step approach. Let's see the how tables looks like when we use a single branching. Let me show you here. Okay. In a single branching, let's say we have the row data. Okay, in which name is mentioned, which is the name Alice, Bob, Carol, and Dave, and their score. So we can provide the condition if score is greater than equal to 90, then it should return the Boolean value, whether it is a true or false, and corresponding result, whether it is a pass or fail. Okay, this can be derived from the Boolean conditions. Okay, we'll similarly implement this into the actual PySpark code. Okay, let's see how the single branch with the case when or when otherwise statement. Okay, let's create the data frame. I have prepared it already. So let's see the data frame using df.show command. There are many more commands to display the results. I am using a show command. Okay, we'll tell you the differences in the different sessions, which display, what type of display command we can use. So display and the show option, there is a number option, truncate. Okay, we can pass it as a false or true value to the truncate. It is depend on the data sizes. Okay, we'll see this in detail later. So we do have the name and score field, in which a name and score provide the 4 records each. Okay, so how the single branching work here? So let's try to select the column from the existing data frame. Let's type a df dot select and select. We'll select the columns. Okay, let's select the name, score, name, score. Now we have selected 2 columns. Let's use a single branching for the case when statement. So the condition here is, if the score is greater than or equal to 19, we should return the result pass. Otherwise, we should return the result fail. Okay, we only have to derive the result column from here, which is this column. Only this column we have to derive based on this condition. Okay, let's try to write this function. So f dot when. So this is also function. That's why we have to utilize functions f dot when. Inside the functions, we have to again use the column functions. So column would be the score. If score is greater than or equal to 19, then what should it return? It should return the pass. Okay. So to what is the other condition? Otherwise condition. So we are continuing in the statement. So the otherwise statement will pass, make it as a fail. So if any case, if it is not greater than or equal to 19, then the candidate considered to be as a fail. So we'll alias it as a result or result. Okay, and let's try to display our data frame. So now there you go. So each score which is greater than 90 has a pass result, so other columns get the fail results. Okay, similarly, if you want to change this condition, if the marks is greater than the 60 or 65, then it should return the pass for 3 columns, 3 rows, and the fail for 1 records. Okay, so what happens if there is a null value in it? Okay, if there is a null value, result should be the null in that case. Okay, so to be precise, to mention this, what is the condition? So it tries to validate the condition and then return the boolean value. Okay, and boolean expression. Okay, and once the boolean is written, it will return the condition value. It will return the condition value. So in second case, this is the fallback mechanism. If it is not matched, the condition return the false, then what is the results? Okay, then it will return the failed results in this case. Okay, so we have discussed how to implement the case when logic inside the PySpark. So this is the single branching when otherwise. So let's move to the multi-branching case when. So it's kind of a grade bucketing example. Okay, let's create this multi-branch when. Okay, so there can be the multiple, like we only added one condition and the other condition. There can we add a multiple condition here with a different where logics. Okay, let's say take the same example. Okay, I will show you one table how we can implement for this one. So let's say this was the example 1, this was the example 2. Okay, how do you have a name, score? Okay, there are the multiple conditions. If the score is greater than equal to 90, then it should return some result and then it should stop the following processes. If the score is greater than equal to 80, then it should return the result and stop the following process. But if it returns a false result, then it should go to validate the next condition, which is if it is greater than equal to 70, then it should return the result. Else, if it is not met, then move to the second condition. So based on that, we will grade the each student based on these values, which is greater than equal to 90, 80, 70, and 60. Okay, let's go back to the Databricks notebook and implement the same logic. So we will use the same data frame, so I would not create it again for you. I will show how data frame is look like. Okay, so try to implement the same logic. Okay, just copy this code and try to implement it. Okay, now we have the condition. I will remove this comment from here. Okay, and try to implement the logic here. So now first logic has been implemented, which is if the result is greater than equal to 90, then it should return the A. Okay, let's give the enter and try to implement the second logic, which is when result is greater than equal to 80, then B, result is greater than equal to 70, result is C. If the result is greater than equal to D, then greater than equal to 60, then it should return the D. Now we have implemented the 4 condition now. So let me try to add a here. So condition, this one goes to 1, this second, this third, and this is the fourth condition. Okay, now we have implemented the 4 conditions here. Based on this condition, we categorize the grade. So this should return the if there is a no score has been given, we should return the unknown value here, and the result should be the name should be for this column. It is a grade. Okay, let's try to run this. So there you go. So if the result is greater than equal to 19, we should get a grade A. If the result is greater than equal to 70, then it should return C. Okay. If the result is greater than equal to 80, it should return a B. Or likewise, if it is a null, then it will return the unknown value there. Okay. So now we have learned about this thing. So there are the shortcuts. So Spark stop evaluating further branches as soon as condition is true. Place the most specific narrow condition first. Okay. So there I have mentioned in the table. So Spark try to validate this condition. If it founds it as a true, it stop processing other condition for the specific record. Okay. Similarly for other. So there is another situations where we can do the conditional logic to handle the nulls. So try to implement that situation as well. So let's see when with the null handling combining with the is null. We'll see is null as well as the when for the null handling. So here let's take a data. If some data has a null value in it, I have prepared it for you. So let's see the data how it looks like. Okay, there you go. You can see Bob has a null score. Okay, how we can handle this null score? So if there is a value null, okay, we have implemented a unknown logic here. Okay, so in this case, what we can do? Okay, so if we run this same query on this data, it should return the null value. Okay, let's try to implement the same query on null value. So there you go. So data condition found the null value, it returns the unknown that we have implemented here. If it is not there, it will return the null there as well. Okay. So how we can handle this using is null. Okay. So for this we can add a either in otherwise we are not sure whether it is a string value, whether it is a non-numeric value. It can return unknown to any specific column or not specific column. Okay, so we should handle the null separately. So how we can handle? We can utilize the second option, which is null. So is null returns the boolean value whether this value is null or not. Okay, and then based on that we can take the decisions. Okay, let's see if I return this column score, we'll use the is null functions here. Okay, then if it is a null, then it should return the out of scope, like or we can mention it as a no score. Okay, so this way we can handle this null value. Now we should get the result as a no score of here. Okay, now we have specifically handled the null, and unknown will return the results for the unknown value, like if there are the spaces in it. Okay, let's try to create the similar kind of a data. Let's change the Carol record to the space. Okay, now Carol does not have anything, but it is having a space here. Now in this case, again we will get the unknown value for that as well and for a null as well. But in this case, we will get the different outputs. For a null, since we have handled it separately, we'll get the no score. For that space, we will get the unknown value there. Okay, this is how we can use a when with is null combination to handle the nulls. Okay, let's move to the null NaN feedbacks. So how we can utilize this? Okay, let's move to the point, which is null and NaN callback using collection and NaN value. Okay, so let's discuss about the coalesce. Okay, so what is coalesce? So in the coalesce, we then if there is a first non-none value, it return the second value. If second is also none, it will return the third value. Okay, let's see how it works in the tabular format. So let's say I have the 3 columns along with the name of the students. Okay, in column 1 we have some value, in column 2 we have some value, in column 3 we have some value, in last column we have some literals. Okay, so what collects will do? If we have provided these 3 columns into the collects, what it will pick? Like, okay, it will check the column 1. Okay, so if column 1 has some non-null value, it will take this value. Okay, if first column is also the null, then it will try to go to the next column, which is a 300. It will take the third column. In third case, if the both column is null, then it will try to take the third column. In fourth case, if the three of the column is null, it will try to take the default value. We can mention, or we can take this literal value from the specific column. Okay, let's go into the Databricks notebook and see how we can implement it. Okay, let's say we have the similar kind of a data that we have discussed. Okay, I have prepared it for you. Let's see how it looks like in the data frame. Now, there you go. Now, there are the three columns along with the name column. So there are many more null. So we try to handle create the one more column, which is bonus column. How much can be evaluated based on these three columns? Okay, let's try to implement a logic. Let's select this column. Let's select. Name has been selected. Now try to implement this logic, Cole's logic. So it is a function. We have to take it from the E of PySpark SQL functions. Okay, inside it we can pass these three of the column. Either we can directly pass this column 1, column 2, column 3, column 4, and we can alias it to the bonus. Okay, now we do have these three columns. Okay, so what happen here is we'll see in the output. Okay, there is an issue with this column. So we have wrongly added this colex function name. Now it is correct. So let's see. So now in the first for first record, which is ls. So since we do have the 500, which is non null value, that's why it return the 500 there. Okay, in the second for Bob, we do have the first non null value, and that's why it take up the value from the column 2. Okay, from third we do have the last column has 100, that's why it taken the, and for Dev every value is a null, that's why it has taken the null value because it is not evaluated. So but we can mention the default value at the end, which is a f dot literal. We can specify any value inside it, which can be 0. Okay, there you go. You can implement that logic as well. So this will take the default value from the last column. Okay, we can explicitly specify the any kind of value. It can be the none value as well. Okay, so we have wrongly implemented this. So none also be implemented via the literal value. Okay, so since we have added a none here, now we will get the null there. Okay, by default this option is activated as a default value. Okay, so this is how collects will work. Okay, so it is the simplest null fill pattern that collects provide us. So more readable than when collects column is null or default otherwise column that we have see previously, which is when otherwise statements. Okay, now we'll move to the next thing, which is a none value. Okay, so in the none value, we'll see how we can implement it, what are the specification and where it is needed. So it replaces the NaN, which is not a number. Okay, so it returns the column 1 if it is not a NaN value. If column 1 is NaN, it returns the column 2 as a fallback. This is specifically for floating point NaN values. So it is a distinct from the SQL none, which is a is none, detects the NaN value. Is null detects the n null. Okay, for you the bonus point here is null detect null value while is man detect NaN not a number value. Okay, this is the bonus point for you. Okay, I think it is not taking the new line here. Maybe yeah, no issues at all. So okay, see in the implementations. Okay, so let me show you one table here. Now there you go. Now we do have the NaN value. So this is implemented from the float value, which is a NaN. Okay, so float is imported from this math functions. Okay, so maybe we can comment it. Let's try to run if it is works without that math function. Yeah, it is able to run without the math function. Okay, now we have created the NaN value in our data frame. So it is different than the null value. Okay, so let's try to select this column. So let's select the df.select. Inside a select, let's take the name. After the name, we can take the next which is a score. Okay, then we can take the score. After the score, try to detect the is nan value. Okay, so we have the function f dot is nan functions. Inside we can provide the score. Okay, whether the score is a null or not, it will detect that. We can alias it as a is underscore nan as a column name. Okay, so there we can detect this. Okay, so the function we are looking for nan value, which is nanvl. Inside the nan value, we have to provide the column name, which is a score. So now we have received the column. Now what we want to replace the if the score is a nan. Okay, we'll try to implement the literal value there. Literal value can be zero or anything, any data types that you want. We can use implement alias as a score clean. Okay, so let's try to visualize this data frame that we have selected. Okay, very well. Now is nan returns the whether the value is nan or not. So there are two values which is a nan, it returns the true. Okay, for this value, so in the third column source clean, it returns the zero value as a default value, which is a literal zero. Okay, so how it is different from the null. So let's try to select the detect the null value instead of a nan. So let's try to implement is null here. So if it is a null, it will return the true or false. Let's try to implement in a separate column. So how it is different than the nan value, we can able to see here. So sorry. So there you go. So if you see is null. Okay. If you see is nan column return the exact value whether this column is nan or not. But is null detection is return the false for every record because nan is not equal to null value. Okay. So this is the way to handle the nan values. Okay. And the nan val function is similar to collects function, but collects function is utilized to handle the nulls to replace the null value with some other column or some default column. Nan val is utilized to implement the or replace the nan value, which is not a number value. Okay, so important here is null and nan is different things in a Spark. Nan is a special floating point value, results 0.0 upon 0.0, which or we can evaluate the nan value using the square root of -1 or different methodologies we do have to return the nan. Okay, so we to detect this we utilize the is nan for an nan and is null for the null value. Okay, let's move to the next point. Six point. None and nan detection using is null and is nan. Okay, so let's move to the is null and is not null detect the null values. Okay, let's take an example data frame I have created for you. Let's see the data frame how it looks like. So it is similar. Name, score, and department has been given to each employee or the students. Okay, so let's try to uh, handle these null values. Okay, how we can handle? We can calculate, count, or return using the is null functions. How we can do this? We can see in this following way. Let's create select the name. Now select the next column, which is score. Select next column, which is department. Okay, now we have selected three of the column. Okay, so try to manage the null values into the score column. How we can manage instead of doing it using the when otherwise statements or case when statements, we can use the is null functions from the Spark SQL functions. Let's type f dot is null in bracket, give the column name which is a score, score, then provide the alias to that column which is score null. Now it should return the null value from the score column. Let's try to visualize how it looks like. There you go. We get the boolean value in this case. Now we have the null for the second occur. That's why it returns the true here. Okay, let's move to handle this kind of situations. Okay, So we'll try to implement this same functionality using the different method, which is like f dot column. Okay, we can pass the score here, and as a method here we can pass this is null as a method, and we can provide a alias here as a score null method 2. Okay, so how we can see both are returning same values for the null handling using is null as a method or is null as a function. Okay, which is identical, both are the identical. Let's try to find whether it is not null or okay using both of the method. Okay, let's find out in the department. Okay, so this way we can get the is not null, and similarly we can implement here as a not null. Both are the similar in this case as well. So I forgot to add a bracket here. There you go. So it returns a true value where the value is not a null. Let's say there in department if the value is null, for this value it returns the false, but for other value it returns the true. It is reverse of is null. Okay. So see, in a similar way we do have the nan values. So now we have discussed the null. Now discuss about the nan values. Okay. So let's create a topic which is nan, detect the nan value. In a similar for this we will prepare the data frame. Okay, I have prepared it for you already. Let's see how it looks like. Okay, for this there is a null and none. Both values are in the value column. Okay, how we can handle this? Let's try to select the column. Okay, df dot select and bracket give the column name. First one is the ID, second one is the value. Okay, third one is the value. Okay, in this case we'll see is none for the value column where the value is there or not. Okay, let's give the alias to this one. Dot alias will provide the name as is nan. Okay. Similarly, we'll try to figure out the is null in the same like in the same column. Okay. Now this is the auto corrected values. We'll see the how data frame is looks like. There you go. For null value we get the true. For none value we get the true in is null column. For nan value we get the true in the is nan column. Okay. So this is how we can manage this. Okay. Similarly, we can implement whether it is not null, then we can try to implement that as is not then not. So this way we do not have the functions available. So for this we have to implement the negation. So negation can be implemented in this way. So we can give the bracket and use this negation symbol. We can use it is above the tab function. We can type it like shift tab. We can get this negation character there. Okay, this way we can reverse the value. Similarly, we can use for other functions as well. Not an issue. Okay. So we'll move forward to the next method, next category, which is a typecasting. So how we can implement the typecasting? Okay, we'll see. So casting is something that changes the column data type. In PySpark, you cast using a dot cast method on any of the column object written by the column method or a literal method or a expr method or etc. Okay, you can pass either a string type name or a Spark data type object. Okay, so there are the different syntax I can show you in here directly. Okay, so let's see the syntax here. So you can use this method which is column. So here it can be utilized as a f dot column, and inside it we can pass the column name and it casts to integer. It is a string shorthand. Okay, for the any casting type. Okay, for the integers or we can add a string here, we can add a float here. Okay, this is shorthand to casting. So second one is the data type object. This is the data type object can be imported from the Spark SQL types. Okay, so this is integer type can be imported from Spark SQL types. Okay, so third one is a as type. Okay, this is a alias for the casting. So similar, both are the identical in a nature. Okay, so let's see the common cast examples. Okay, So let's take a step-by-step examples. Before that, we'll see the converger reference table, how it looks like, and how we can proceed with the taking the reference from this table. Let's say from type string type, we have to convert it to the string type. Okay, so string alias can be used as a int or integer. Okay, if you use the string shorthands to typecasting. Okay, so if you call to cast string type into the integer type, it fails and return the null if string is not a numeric. In this, if you can try to convert a string type to the double type, there is a shorthand for this double or float. Okay, it follows a numeric string. Okay, if the string type is actually not an integer or a double type, it will return the null in this case as well. If you try to cast a string type to the date type, if the string contains the date formats, okay, it will expect in the YYY format, then it will cast to the date format. Else again it will return the null in this case. If you try to cast a string type into the timestamp, then it is expecting the ISO 8601 format. If it is not in that format, it will return the null in this case as well. If you try to convert integer to string type, it always succeeds because every integer can be converted to the string data type. Okay, if you try to double type into the integer type, okay, then it will truncate the decimal, like means it won't round anything. It just truncate the decimal here. Okay, if you try to convert a boolean type into the integer type, okay, if it is a 2, it returns a 1. If it is false, it returns a 0 in this case. If you try to convert any types into the string type, okay, it is also casting and always work, and it also avoid the data losses in this case. So let's see the examples for this type castings. Okay, so I have prepared one data set for you. Let's go to the Databricks notebook. Df.show. See how data it looks like. So we will get this data. First one is ID in a string format, score in string format, date also in the string format. Okay, we'll try to convert into the integer, double, date, or integer type or boolean. Okay, let's try to convert this, cast this data. Okay, so first one, let's try to select in bracket. We'll provide the, we'll take the columns. Okay, so first column could be like f dot column in bracket. Let's take a ID string column. Sorry, ID string column. Let's type to cast it. So casting to this string column into the integer or int can be, both can be utilized. Okay, we'll give it as a alias ID in int format. Okay, let's try to cast the second column. So second column is score string. Okay, we'll cast it to the, sorry, cast it to the double. Double. So double can be float. Alias it to the score underscore tbl. Okay, so again try to cast the next column, which is f dot column first date string. Try to cast it to the date format. Okay, so give the alias as a event date. Event date. Okay, now we have done with the casting. Let's try to visualize this. So the column is not a callable. Maybe I have made a mistake in taking the column. So I have added a case instead of a case instead of cast. Now there you go. Each and every column get as it is. Okay, so no issues have been found. Since the date format in YYMMDT format, it is able to cast. Score DBL is into the kind of a double format, so it is able to cast that column into the double. Okay, let's try to cast the column ID column into the integer using the integer type that can be imported from PySpark SQL types. Okay, let's try to cast that as well. F dot column ID string dot cast. So a casting could be integer type. So now this needs to be imported from the SQL types. Okay, so how we can import that ID int p. So to import this, we have to execute one more command, which is from PySpark.sql.functions import in integer type So from types, you can imported integer type, and now we have added it over here. Okay, let's try to run this. Now we are able to get this thing. Okay, so now we are done with the 7 categories, which is column reference functions, which is column and expressions, literal value functions, which is lit and type lit. Actually, it is the array functions. Okay, in a conditional logic, we use multi-level, single level, and the null handling with the when and otherwise statements. We also are able to handle the null non using the fallback method using colleagues and non-val functions. We are able to detect the null and non function using is null, is none, or is not null functions. Okay, we are able to do the typecasting between the int, double, string, date, and other data types that can be imported from the SQL types. There are many more data types that can be seen. Okay, so for now we have seen the integer types. So that's all for today. We'll discuss other categories which are remaining in this session of the normal functions. We'll see in next lecture, which can be collections, row ID and partition, random values, hashing, broadcast hints, and source metadata. Thank you. Keep learning, keep sharing.